Everyone. So today we're talking about, or we're starting to talk about what's called a system of equations. And a system is any two equations that, or really two or more equations, but it's multiple equations that involve the same variables. Okay. And so when you're looking at a system, each equation individually may have lots and lots of solutions. Think about like a y equals 3x plus 5. There's tons of coordinates that would make that true. That's why we draw the line, okay? And then that represents all of the possible solutions to one of the equations. The solution of the system, however, has to be one specific set of variables that make all the equations true at one time, okay? And so there's a lot of different ways you can solve systems. Today we're really just focusing on solving them by using graphing. And I'm going to do this example today by hand, but then I think in class we'll probably have to circle back and talk about how to do things with your calculator. Either that or I may post a second video that's got a demonstration of how to do some of this on your calculator. Okay, but for today I really just want to focus on graphing by hand and what it means to be a solution to a system. Okay, so I'm just going to kind of go through this first example. I'm not even going to hit the second example in this video because, like I said, I may do a separate one later that talks about your calculator. But so we've got two linear equations here, right? And each equation by itself would form a line because these are linear, all right? And we know how to graph these. So like this first one, my y-intercept is -4. My slope is 1 over 3, so I would go up 1 and over 3. And all of these points that I'm plotting represent solutions to that one equation. So all of these points would make this first equation true. And then even when I connect them with a line, and I might go a few in the other direction as well, just make sure my line's nice and straight. Even when I connect them with my line, that line represents all of the points that are solutions to this equation, okay? So every point on that line, whether it's one of the points that I sort of highlighted or whether it's a point kind of in between, all of those are solutions to that one equation. And then I can do the same thing with the other equation. So this one would start up at +4. And then my slope here is -1, which I can really think of as -1 over 1. So I'm going to go down and over, down and over, down and over, okay? And when I do that, and when I connect them, you'll see, oh, I think I missed the mark there, that these two lines should share one common solution. I'm pretty sure it's supposed to be this point. Let's just check here. This should have been here and here and here. So yeah, I drew my line a little badly. But this point right here would represent the solution to my system. Okay, so each line by itself has a whole bunch of solutions, right? But then there's one solution that they share in common, and that's called the solution to the system, okay? So just so you know, we did this all just visually with a graph, but you could also look at this in like an XY table, all right? And that's what the calculator piece is going to get into, but I know there's some problems in your homework that talk about like an XY table. And so if you set up a table, normally we go X and Y, but what you could also do is do y1 and y2. And then choose, whatever x's you want. So, I don't know, 0, 2, 4, 6, and so on. And then plug those x values into the first equation, which we'll call y1. So let's see. No, I didn't pick very nice numbers for that, did I? I don't think we need to necessarily go through it all completely, but plug your x's in, get your y values for equation 1, then plug your x's in here and get your y values for equation 2. And what you're going to see, and I just want to find where the solution actually is. Solution is at 6, -2. When I plug 6 into this first equation, 1/3 times 6 would be 2, and 2 minus 4 is -2. When I plug 6 into this equation, that negative would make it -6, and then -6 plus 4 is also -2. When I see this in my table where my two y values are exactly the same, that's another way I can tell that that's a solution. So I can see it on the graph, I can see it in the table, and obviously there would be other numbers filled in here. I just didn't pick nice numbers to fill in that table. But this is what I'm looking for.
Sierra Herman,
Ignore that.
Brian Dwa, Ryan.
But that's really about it as far as solving systems by graphing. That's really all you're going to need to know for right now. Like I said, I would like to talk about how to do some of these things on your calculator. Oh, you know what? There is one more thing I kind of wanted to touch on is we're used to graphing lines, right? And for the most part, you will be graphing lines here. But it is also possible for a system to have, like, say, a parabola in it. So you could have like a parabola like this, and then a line kind of coming across it like that. And then this system would actually have two solutions. You would have a solution here and a solution here. So totally possible to have multiple solutions to one of these things. Also, so let me just jot down that this would be two solutions. The other thing you might run into, and I actually don't think you'll run into it yet, but soon, totally possible for you to have something like this, where you have like a parabola up here and a line here, and then you have no solution because those things don't cross, okay? So these two things are total possibilities too. So up here you had an example of one solution, here you had two solutions, here you had no solutions at all. Okay, hopefully that was helpful. It was short but sweet today. But that's really all you're going to need to get started on your homework. Like I said, I might do a calculator demo and post that video as well. Okay, thanks for your time.